Hello and Assalamualaikum. So I will give you a lecture about the Laplace transform. So I'm going to be quick in this lecture. So the first of all, what is the purpose of Laplace transform? So the purpose is to transform integral equation or differential equation into algebraic equation. So why we want to transform both integral and differential equations into algebraic equation is because it is easier to be solved. Okay, so that means integral and differential equation is difficult to be solved. So when we transform it by using Laplace transform into algebraic equation, it is easier to be solved. Okay. So this is the Laplace transform operator denoted by this L. So when we transform, we usually use small f for the t-domain function, and after the transformation, we will use big F for the function in S domain. So this is the equation that you need to memorize. First, we have the integral, where the upper limit is infinity and lower limit is 0. And we have exponential, where it powered by negative st. And we have the function. And lastly, dt. Okay. So, some information that we need to know about Laplace transform is, first, it will transform the small f function in the t domain or time domain into the S domain function with we use big F. So we will have function of S, and it also called frequency domain. And after we solve in this algebraic equation, which is simpler, after we solve it, we can inverse transform back to the original t domain function if we want to transform back. Okay. Sometimes we don't have to transform, we just get the answer, and then we can use the answer in our application. Okay. And we need to know that the upper limit is infinite, therefore is one type of improper integral. So the upper limit is infinity. So we can use this kind of equation. So where the limiting case is t approaching infinity, so we replace infinity with t, and we want to see whether this function will be, after we do the integration, we replace t and 0 inside the integral, and we want to see whether the function will diverge or it will converge. So if it is diverging, it is not applicable for Laplace transform, is not applicable. But if it is converging, therefore Laplace transform is applicable in this function. Alright. So we need to have a condition. We need to apply condition for this function to be applicable for Laplace transform. We will talk about that after this. The third information that we need to know is the lower limit is 0. Therefore, for the function, this function, we ignore the anything. If this is the line of the function, we want to ignore the negative part. Usually time don't have negative, we don't consider negative time, so we just consider the positive side only. Same goes to the, when we transform it, we ignore the negative part. Okay. So actually not always negative, it can be any value based on the function that we use. So if we want to consider negative side, we also can consider that by using other type of Laplace transform, which is two-sided Laplace transform or bilateral Laplace transform. So the integral will look like this, where the upper and the lower limit is infinity, but actually this one is negative infinity. Okay. So this is the content of the lecture. First, we will learn about how to transform simple functions in example 1 and 4, and then we will learn about existence of Laplace transform. This is we will learn about the condition for the Laplace transform to be applicable. Okay. And the second one is property of the Laplace transform. We will learn about the first one, the linearity property, the first shift property, and the last one, derivative of transform property. Okay. So this is the example related to the properties. And last one, we will learn about Laplace transform table. Actually, from this example, we will derive the formulas, and we put it everything, we compile it in this Laplace transform table. Okay.